I'm Elena Simparl. I'm part of the European Data Portal team. Welcome to this new edition of our Futures of Open Data Portal series. And today we're welcoming Julia Elliott from Google, from the Kaggle team. Julia leads the competitions team at Kaggle, which I'm sure many of you know as one of the most important data science resource and the world's largest data science community. She works with organizations to design competitions that aim to solve difficult machine learning problems with the help of the community. She holds a degree in electrical engineering from Pennsylvania, MBA from North Carolina, and she spent earlier part of her career in technology consulting and project management, and then building operations and customer success functions in startups. She is now at Kaggle, and she will talk about her experience there in building that community and the data science ecosystem that comes with it. Julia, thank you so much for being here with us today, and we're very much looking forward to your talk.
Thank you, Elena, for that introduction. Hi, as Elena mentioned, I am Julia Elliott. I lead Kaggle's competitions team, and I'm really excited to be sharing with you today about basically my job, which I'm more than excited to talk about. I'm going to talk a little bit about Kaggle. I'm going to start out by giving you an introduction for those who don't know who Kaggle is or what Kaggle is. I'll talk a little bit about Kaggle Competitions specifically, because that's my day-to-day, as well as our vision for Kaggle as an ecosystem. I know that this talk is really centered around how we've built this Kaggle community and data portals, and how we've created a data science community. So then I'll talk about who is in our community and how we've built that community, and then what's next, where we're going, how we're growing. So I'll jump right into it. So Kaggle, for those who don't know, is the world's largest data science community. We have over 5 million users at this point who come to Kaggle to learn and share data science. And you might be asking, 5 million, wow, that's pretty incredible. What are they coming to Kaggle for? So we have 3 key product areas, and throughout this talk, I hope you'll take away a little bit of detail about all of those. But to give you kind of a little bit of an overview, the first, as I mentioned, are machine learning competitions, where a host brings a problem that they're looking for our community to solve, and will pay prize money in exchange for the solutions to those problems. Second are what we call notebooks. These are, if you're familiar with data science, Jupyter notebooks, or a cloud-based code for sharing data science models or exploration. And third are data sets. Data sets are on Kaggle are all public. So this is kind of an ecosystem for people to just share those data sets. As you may be aware, data sets often can enrich the modeling that is done. And so we like to bring in all different kinds of data sets from wherever about whatever topic. All right, so where I'm going to start is to talk a little bit about my day job, which is Kaggle Competitions. It's also the anchor product for Kaggle. It's what people most know Kaggle for. And I thought it would be a nice starting point to kind of grow and show how we've also evolved, because competitions were actually where we started before we had all of these other product areas. And it's also kind of a nice primer to machine learning for those of you that aren't aware of what supervised machine learning actually is. I hope to give you kind of a very layman's explanation. So Kaggle hosts supervised machine learning competitions. And so this is a screenshot of a recent screenshot, actually, of a listing of competitions that we are running or have been running. This listing is obviously refreshed over time, and each competition runs for about 2 to 3 months. It also kind of gives you just a little bit of a sense for the types of competitions that we run. I'll go into a little bit more detail about the use cases that we see customers running. But as you can see, each competition has a host. So this is either a commercial organization or a research organization who is looking to solve a very specific predictive problem. So they have something in mind that they're trying to solve. And people from our community are able to submit predictions to that problem over the course of the competition. And at the end of the competition, whoever ranks, usually in the top 3 or 5, will receive prize money in exchange for models that they have created to solve that problem. So I'll talk a little bit more about what a supervised machine learning competition is next. So it's very simple, actually. The concept is really using your training to inform predictions on the test set. So we start out with training data, and this is what people use that we provide, or the host provides, to build their algorithms. This is the data that has the ground truth. And then we have the test data, and that's really what we're testing them on, as the name would suggest. This is where we've withheld that ground truth and are asking for participants to supply those answers. And then we measure them on the accuracy of those answers, because we actually have those answers, or the host has given those to us in the background. And so, giving a really rudimentary, simplified example, assume that we're talking about a basic insurance problem, where you're trying to determine whether or not someone will file a claim based on the information that you have about them. Training data could be composed of things like age, income, etc. Obviously, all privacy protected. And then the claim filed would be the ground truth column, or our target variable. Maybe a simple binary classification of true or false. And so people will build their models based on this training data to predict the claim filed result. And then we have a set of test data where that result has been withheld, and they are asked to run their models on that test data to give us the claim filed result, to give us the ground truth prediction. And we know those answers, and we are able to evaluate them on the accuracy of those and spit out a score, an accuracy score for their submission. So they make these submissions over a 2 to 3 month period that the competition runs for, and they're able to see on the leaderboard where they rank. And so this is kind of the secret sauce of Kaggle competitions, and what makes them, and many people in our community would say, very addictive. So these are people that typically have day jobs themselves, and I'll talk a little bit more about the composition of the community in the next coming slides. But they are driven to keep trying to outpace one another over time. And so you can see, on this screenshot of a leaderboard, and when the competition closed, kind of the score they were receiving, as well as how many entries that they made, and then the people in their team, so that you're able to have team members as well. And so the key to this sort of competitive dynamic is that we believe that competitions over time are able to extract all the signal from the data set, and actually quite quickly, because of how adept our community members are. So I'll give you kind of a pretty simplified example of an actual competition's progress over time, and measured with the accuracy measurement on the vertical axis here. So in this case, this is an error measurement, which means that the lower the error, the better. So our first submitter on this competition was Martin O'Leary, and this was like a science related competition. He made a submission. He thought he did pretty well. By all accounts, he placed on the leaderboard. He didn't have any errors come out of his submission, and he might have stopped there, right? In any data science maybe team, if you're working in isolation, you might make a submission and then think that you've done pretty well. However, quickly thereafter, he was outpaced by another team. And then he was driven to go and try to beat that other team, and so you can see him in the orange here, as he continues to try to outpace the others. And over time, what we see, and this is very consistently in virtually every competition, is this convergence on sort of what we believe to be the best that is possible on that problem for that metric. And so this is kind of really what drives people and motivates people to try to continue to work on the problem throughout the course of the competition. We obviously have a very large and growing, I'm running out of room to fit the logos, variety of companies and organizations who are running Kaggle competitions. And this logo board, more than just a vanity metric, is actually intended to show kind of the diversity of the types of companies that run competitions, all the way from, your pharmaceutical companies to your tech companies, to retail and beyond. And so you might be wondering, well, how do you apply, you're wrapping your head around the concept of what a supervised machine learning competition is, and you're wondering what kind of use cases these companies are actually running. So that's what I'll talk about next. So the types of use cases that customers bring to us fall into a couple categories, and they're very common machine learning problems that you might see in industry. And so the first is probably, many people have heard about this, is what you call the recommender system. An example of this was Airbnb coming to us to predict a user's first booking. And the idea is that a marketing group or whomever can then use that information to know how to promote certain things, or where to maybe place buttons to improve click-through rate. Sales forecasting. So this can come in a lot of forms. It can be grocery sales. It can be, in this case, the example that I gave was Zillow, which is I think, US-based home sales search engine. So in this case, they have something called the Zestimate, and they wanted to improve the prediction of a home sales value. And so that's, a type of sales forecasting where you have a lot of historical sales information and you're looking to predict the future of sales. Event prediction. So this is very simplified, a way of saying that you're just trying to predict whether or not something will happen. The example I give here is home credit. So predicting whether or not someone will repay a loan. The example I gave previously, the very simplified loan claim filed example, is also another example of event prediction. Natural language processing is a growing area in machine learning. As you might imagine, understanding speech and in different languages is very difficult. I mean, even for the human brain to process sometimes. Understanding whether someone is being sarcastic versus being toxic can be challenging. And so actually Google, our home company, was looking to classify toxic comments, and this is readily used in situations where you're trying to get ahead of toxicity before it kind of permeates and creates negative vibes in a community. The first of two image examples is image classification. So this is where you're simply trying to classify something about an image. A very simple example might be like, does this image contain a dog or a cat? In this example, more serious example, the Transportation Security Administration in the US was looking to detect whether or not there were threat objects on a body scan. So it's this little screen, this little image to the right when you go through airport security in the US or elsewhere, and people kind of, scan your body. They want to know whether or not there are any objects there that should warrant a secondary search. And they don't want to overdo it, right? They don't want to have too many false positives because that means that people are delayed for their flights, and that's frustrating. The second image example is an image segmentation problem, slightly different, a bit more complex, where you're trying to not just identify whether there is something yes or no about an image, but where exactly that image, that object is. So Airbus, for example, was trying to identify ships in satellite imagery. So they're trying to see where there are ships in an image taken from a satellite. And lastly, predictive maintenance. This is where they're trying to predict some kind of a failure or some type of an event in, for example, an assembly line. And so Bosch came to us looking to do that, to do just that. All right, so that kind of is the very quick overview of what a Kaggle competition is, but I'm not just here to talk about competitions. And I really want to talk a little bit about how we believe we've made our ecosystem successful. And at the core of that, at the heart of that, is really our vision for how Kaggle operates and why we've brought these products to our community. So the first being our community, so the people, right? So the people themselves and the things that they share and the things that they want to learn really drive and sit at the heart of our community. The second piece of this three-legged stool are the data sets. So we believe that people are coming to look for data sets to enrich and enhance their work and their projects. And then the third part of this is reproducible code or notebooks. And so the idea is that we're able to surface an environment for people to actually create the code for their work or for their projects. And so each of these three items in isolation might not be quite successful in creating our ecosystem, but these three components in tandem really enrich and kind of create sort of this virtuous cycle of engagement within our community. And so what I'll kind of talk a little bit about next are kind of each of these three areas. And then I will hone in a little bit more on the community aspect of Kaggle. So ultimately, when time and again, when we talk to our community and ask them, why are you here? Why are you coming to Kaggle? It's really not just about the products and the maybe winning prize money, because let's face it, only a couple people are going to win prize money. It's really about learning and sharing. It's about people who are all coming with a common sense of interest in data science and growing. Data science is obviously a growing and prevailing field, and therefore many people are in various stages of learning data science, and maybe not directly practitioners today. Maybe they are marketing executive or analyst who is looking to build their tool set, expand their tool set into new prevailing trends like data science in order to better do their job. And so we see people using Kaggle to really share all the work that they've done if they are experienced, or consume that work that has been shared. And so that constant kind of vibrancy of the community is developed over time due to the content sharing that people are doing. And so that content comes in a couple different forms. First is discussion forums, and it's where people are able to, for the course of a competition, kind of talk a little bit about, what kind of approach are you taking? Have you tried this type of, neural network? Have you, how are you thinking about your cross-validation, et cetera? And then at the end of a competition, there's like kind of this beauty in everyone within usually the top 100 sharing their actual approaches, sharing what worked and what didn't work. And this like really nice dynamic that we have in our community of people just really being willing to pour out their hearts into what they've worked on collectively for the last 2 to 3 months. Notebooks are the second area. I've mentioned this before, where people are sharing their actual code. So like in the discussion forums, this is actual physical code. And the nice thing about this is that you're no longer in data science starting with what we call a blinking cursor, which is where you have like, your coding environment open and you're saying, okay, I want to create a recommender system for this data set, and you have no idea where to start. You can start with an actual notebook that someone has created, maybe doing something very similar to what you're doing, but maybe on a different data set. You can copy and edit or fork that data set, or sorry, that notebook, and incorporate some of the things that you're working on. So it's a nice way of getting started when you are new to machine learning or just new to the topic that you're trying to tackle. I mentioned data sets. So this is kind of like that third part of the stool where we are also providing public data sets to enrich those algorithms. Also, just to give people a place. Sometimes, people often say that when they're looking to get started in data science, one of the hardest things is just finding a clean data set to work with. One that is kind of free of a lot of superfluous columns or features, and just really trying to cut to the chase so that they can get to the work rather than the cleaning. And so that's what the public datasets platform is aiming to do. And then lastly is kind of a newer area of Kaggle is where people can actually learn. So we've built a series of courses taught through Kaggle notebooks with a bunch of different topics, all the way from like your basic intro to machine learning to Python and SQL and advanced techniques. And these modules are taught through notebooks, which means that you can also, just like you do with notebooks, fork them, play with them, and then in order to complete each of these modules. All right, so next, you're probably wondering the types of people that come to our community. And so who is Kaggle? So when I say who is Kaggle, I'm not talking about the people like me who run Kaggle. I'm actually talking about our heart, which is the people in our community. So we actually have run an annual machine learning and data science survey. And so this is where I'm pulling a lot of the data here. Uh, and over time, submission to this survey has grown. So we just released this survey, the 2020 version of the survey, within the last couple of weeks. So I'm pretty excited to share some of the latest here. So from a gender standpoint, we are seeing, like in the data science world more broadly, a male sort of dominated field. This is an area where we've seen women increase in participation over the last few years that we've run this, but obviously an area where we have much better to do, both to impact data science more broadly and also specifically at Kaggle. And so that's for gender. This is age. We are seeing that this is kind of a early or mid-career type tilt in terms of who is present in our community. And so people who are, have some experience in industry, but are kind of between their 20s and their 30s, are the types of people that we usually see at Kaggle. Also, we asked about education. And so one thing that might be surprising is that we actually see a lot of advanced degree holders at Kaggle. So you'll see master's degree is probably the prevailing population here. And so in addition to the fact that many people are actually doing a lot of this learning through massive online courses, so people are also taking new sort of online methods to attaining these degrees. From a profession standpoint, many are students because obviously they're at Kaggle to learn. These are students who are either in their undergraduate, or even many are actually in their graduate careers. And then we have the next largest group are the actual people who refer to themselves as data scientists, but then a long tail of software engineers, analysts, people who are probably doing data science as a portion, but maybe not the only part of their job. So that's also kind of interesting. From a geography standpoint, this has kind of shifted a little bit over time. The US, because we are based in the US, and India are kind of our top countries. I pulled this as from a time period over the last 2 months. So Ireland isn't usually 3, but if you kind of group together Ireland through number 3 through number 8 roughly, you'll see kind of that trend of long tail of larger participation countries that we see. So those countries collectively are all quite well represented on Kaggle as sort of the third runner-up behind the US and India. China is probably underrepresented in this list because many of those folks go through a VPN, and so their IPs are not quite captured as associated with China. So we probably see in the top United States, India, and then China, and then a long tail of other countries that you see listed here. So we are very global, is kind of the point of this slide, is that we are represented in over 90 countries. And so it's a very vibrant global community. All right, so we have all these people, and now you know a little bit more about who they are. Now I'm going to talk a little bit about how we build that community and how we engage them. That's basically my job. And so I'm happy to kind of share a little bit. Um, the first thing, and maybe not the most fun, but necessary component is community guidelines, how people should be treating each other in Kaggle. We are very fortunate to have a community that is quite welcoming and well behaved, I guess. Um, and so people are there because they're there for, often professional or academic reasons. We find that we're able to kind of filter out many of the bad actors that a community might ordinarily encounter. But nonetheless, we do want to, take a firm stance on how people should treat each other within the community and in life. And so we did introduce a set of community guidelines in the last couple of years, and for the most part, we don't have to act too harshly on these when people are in violation, but there is still this kind of mantra that we stand by as a community. And it sets the tone for kind of like how people act on Kaggle as well. So I mentioned before that, it's kind of this, we've built a community that is already naturally sort of centered around learning and sharing. And that's really kind of evident when you kind of read through our forums or the things that people are sharing. This is just kind of a random snippet that I picked, but people are trying to get their hands on and understand prevailing technologies that are introduced in data science, and they can come to Kaggle and ask the dumb questions because no question is too dumb, and get answers and hear a little bit more about a different way of approaching what they might be looking at. One component that I think has varying degrees of success depending on just individual personalities is a rankings and progression system that we have also integrated. We integrated this quite early as a way to really motivate people. I mean, why would you want to try to climb a leaderboard if you're not going to be in the top 3? The idea is that we award what we call medals to individuals for certain types of achievements or certain types of public sharing. And then over time, you kind of grow from being a novice to a contributor to being an expert. Master and grandmasters is one we've introduced in the last 5 years. And so over time, you kind of see who is outpacing each other. So it's kind of like a leaderboard for the whole community. And I say that this has varying degrees of success because many people are not competitive in this way. And so this does appeal to some folks, and it doesn't appeal to others. The other thing we have is all centered around this idea that we're a place for learning and sharing is we also hold virtual events and videos. So we've been doing this even, pre-COVID, where we have these kind of machine learning events, learning about different things, how to, get started. We have these like SQL summer camps where people, for a couple weeks are all consuming content on a daily basis that we trickle out. And the reason for, we've been doing this for a while is because obviously we're a global community, so we can't possibly physically reach everybody. So this is a nice way to keep people engaged. And when we were able to, meetups. So we started this concept in the last 2 years called Kaggle Days, where we were actually hosting both large scale global events, for a couple hundred people in each country that were interested in attending, all the way to also just like individually hosted meetups that maybe a particularly enthusiastic community member was interested in holding in their local region. And so we see a lot of this very organic meetup behavior, even not in person. Like we see it on Slack. People create groups and they all want to know, who are all the people in Brussels who like to work on Kaggle, and then they kind of all congregate together in Slack or virtually. So those are kind of the components of how we've really kind of I don't want to say incentivized community, or sort of try to motivate our community to kind of grow and flourish. The last section of my talk here is to talk a little bit about where we're going. So, the evolution of Kaggle, as I've talked about, has been sort of starting with the idea of machine learning competitions, and then tacking on these other product areas around that central mission to help people learn from data science. So the notebooks platform, the datasets platform are all kind of feeding into this idea that that people can use these different product areas to really grow in their learning and in their work. And now we have kind of a really nice set of core products for people to learn and grow from data science. And so what we're hoping to do is continue to motivate content sharing. And that means introducing, on the left-hand side, our competitions listing, introducing as many competitions from as many different sectors, data types, industries as possible, so that when you do come to Kaggle, you can find something that's appealing to you, and that is relevant to what you are trying to do. So, oh, you work with audio files. Maybe you're interested in the rainforest species audio detection competition, or maybe you're really interested in American football. You want to and you want to work with video data. Here's a competition for you. And so my team's goal is really to kind of help customers obviously host their competitions, but as many different types of competitions as possible, so that someone out there who's in our community can find something that's appealing to them. On the right-hand side are the actual public data sets that we have, and these are some of the prevailing ones, but to constantly replenish this repository of data sets with as many different types of data sets as possible, just like the concept with the competitions. So you can see, one of the newer topics, US election tweets. We also have things about food, airport traffic, and ideally you can find anything on Kaggle that you want to work with. And again, really trying to incentivize and motivate content sharing across our community. We are also venturing into advanced competition formats. There is an area of machine learning called reinforcement learning, where you're essentially training your model to train itself. And it's a growing area, and obviously a complicated one. But one application of that in sort of a more fun note is to do sort of bot-driven games. And so the left-hand side screenshot is actually an example of a competition we hosted called Haylight, in partnership with 2 Sigma, which is where you're trying to kind of create your bots that can capture something within the board. But you're fighting against another team who's also trying to do the same thing. And so you're trying to learn about their approach as well as move your own people. And then you might be familiar with the board game Connect 4. So on the right hand side, it's our version of that called Connect X, where you're trying to get 4 in a row in any direction. And again, this is the idea that you're playing against someone else and trying to advance your team ahead of the other. And so these concepts are very difficult in or considered more advanced in machine learning, and so we want to be able to bring in the name of more diverse content. We want to be able to bring these advanced formats as well. We have been trying to take initiatives to also expand diversity and inclusion on Kaggle, recognizing that each year as we do our survey and also just the day-to-day interaction with our community, its composition could use much more diversity in both gender, race, etc., and geography. And so we hope we have been taking some targeted initiatives around growing diversity and inclusion on Kaggle, so that we can not just improve Kaggle's richness, but also hopefully have an impact on data science more broadly, giving other people who might not even be part of Kaggle, a reason to want to come and join. One of the examples of this is we've been experimenting with what we call community initiatives. So we launched in the last couple of weeks something called Communities, which is where we take discussions kind of to the next level. Instead of just having this kind of like open sea of places where you can just contribute or ask questions, we have these targeted sort of community groups where people are actually able to ask questions in maybe a room of people who are interested in that same topic. So these are all kind of areas of machine learning that are prevailing. And the idea is that you come to Kaggle and you can, if maybe a competition isn't suited to what you're interested in, maybe you can come and work within a group of people who have like interests. And that wraps up my talk. I hope that you have learned a little bit about Kaggle, both what we are as a competitions platform, which is what we're most well known for, all the way through to our notebooks, data sets, and other aspects, and also just how we built our community. Thank you very much. And Elena or someone else, I'm happy to take questions or, yeah.
Thank you so much. So I mean, some of us know Kaggle, but obviously when we hear a talk like this from someone who has first access and shapes the product is truly fascinating. The range of activities and interventions and features of the platform. So I have a few questions myself, but I'll start with the ones that people have asked via the chat. So Mihalis is asking, is the code or the solutions, I suppose, that people submit in the competitions,
Mm-hmm.
are these owned by the clients or are they open?
Great question. So the short answer is they are either open if the individual chooses them to be so, or they are private. They default to private, obviously, because you wouldn't want to unnecessarily give away all of your secrets before the competition closes. But at the end of a competition, whoever is ranked in the top of the competition, so usually top 3 to 5, as part of their participation in that competition, would be required to provide the code for their solution in the way that the host requests it. Sometimes it's open source, that code. Sometimes it's provide a license to the host in exchange for that prize money. And so if an individual opts, not to accept a prize money, then that wouldn't be part of the arrangement. But the idea is that, the company is paying for the solution. And so for those solutions, then that becomes that becomes licensed in the way that the host requests. But generally speaking, on Kaggle, if you publish something publicly, that automatically has like an Apache license, I believe, tied to it. But if you choose just to keep your work private and just, submit to competitions, that doesn't by default become property of Google or the host unless it becomes public.
Okay, thank you for that. Hayo is asking a question about the 60,000 data sets that you mentioned. So from what sources or organizations do these data sets come? And are there any government data sets or public sector data sets?
Yeah, great question. So they come from everywhere, to be quite honest. Sometimes it's an individual who has found the data set from another source, but has verified that that source is or that data set has been licensed for public use, and so they've decided to share it. Some of this, like the football. So soccer statistics, for example, sometimes people are just so passionate about it. We even had like someone come, they loved Game of Thrones and they wanted to publish a data set about all the people that got killed in different seasons. And so that's all, organically produced data sets based on each person's individual passions. And yes, government organizations are publishing. So the other thing Kaggle, we behind the scenes are doing, are also trying to reach out to organizations to bring their data sets to Kaggle, especially if we see a lot of interest around it. So as much as possible, we are trying to bring already known public data sets that are out there that might be kind of in silos into Kaggle so that it's available to more people. I'd say we would love to have more government data sets. There's so many things out there. Many of them, of course, I imagine have some public restrictions. And so the idea is that on Kaggle, these should be publicly available. So.
Okay, thank you for that. Adam, just about when I was going to ask a question, Adam asks one as well. If the prize money is large enough, what is to stop the top 2 or 3 people or teams on the leaderboard to collude to win the money?
Yeah, we have a lot of rules. So every competition is technically hosted by the host of the competition. And when someone enters the competition, when a participant joins the competition, in order to gain access to the data set for that competition, they have to accept that competition's rules. And that those rules specify the winner's obligations, how they have to turn over the code, what license they have to use. It specifies the data access license. Can it only be used for the purposes of that competition? Can it be used for academic use? Can it be used for commercial use, etc.? And we also have one of the core things that participants learn about Kaggle competitions is our multiple accounts holding and collusion rules. And so that means that I can't go on and compete in Kaggle and then create another account and then compete on Kaggle also so that I can gain more submissions. I also can't be working with my friend that's working next to me, and we each have our own accounts, and do as you suggest, Adam. And we have many ways that we don't reveal of catching people who do this, and our methods have become more sophisticated as people who have tried to cheat have become more sophisticated as well. And so we are constantly evolving those algorithms. We have algorithms ourselves that are looking for bad actors. And as a very last sort of stage gate is also the ability, so each host, because they are actually receiving the code, is also able to verify that that code doesn't have anything in it that would suggest foul play. There has been little, I guess, consequence of this in the sense that we haven't actually seen people do this in the top rankings very much. We've had maybe 1 or 2 incidents I can think of, and they were quite complex in the way that they tried to cheat the system, but we did identify them, and so there is it usually results in a true meritocracy where people are actually ending up on the top of the leaderboard because of their results.
This very much reminds me of the sort of speeches I give to my students who are submitting programming coursework. Very similar. We have algorithms, they work, you're getting better, we're getting better as well.
Yeah,
You have
exactly.
science, the academic integrity. I guess, yeah, I mean, it's a fair question, but it's also fair to say that lots of people are honest and are there because they want to prove themselves that they are able to win and advance in their skills, and is what you're saying earlier about learning being a motivator rather than the prize as well.
Yeah.
I'm going to ask one of my questions and then go back to Mihalis. You asked the second one. I've done a bit of work in open innovation and in challenges in general, and one of the experiences I had, one of the most challenging part is that in the design phase, that stage where you have to talk to the problem owner or the host, as you call them, and carve out a problem that is interesting enough for them and useful enough for them, but sort of self-contained, in the sense that it can be solved in this format rather than being more broader or more explorative. And I was wondering if you have any sort of thoughts about how do you identify a client problem that is
Mhm.
suitable for a machine learning competition, and which problems perhaps are too big or less suitable, less interesting?
Yeah, that's a really good question. So this is what I deal with day to day, is trying to make competitions that hosts bring us into real launches that happen on Kaggle. I will say it, as you suggest, it is very difficult. The process is usually our sales cycle, to give you a sense, is about 6 months, if not more, which means the point from which someone brings us an idea as an inbound lead all the way until we actually do launch their competition. And the longest part of that is as you say, identifying the data set and the problem that is a good fit for Kaggle. The fact is that Kaggle's supervised machine learning competitions, something that we're actually often criticized for, which we accept, is that it's very niche. So it's very specific. So we're looking for a very well formulated, clean data set. That people can jump into right away. And that's by design. We don't want people to spend a lot of time cleaning up the data set as much as possible. And then predicting something very specific. And so oftentimes we do have folks come to us where they're looking to maybe predict multiple things, or they're looking to have multiple metrics to measure, or maybe their data set is not quite large enough, or they're trying to do unsupervised machine learning where they don't actually have the ground truth. And all of these are reasons that we actually, unfortunately, have to decline the project because we are very focused on the specific type of competitions that we run. And that's not to say that you can't gain something from Kaggle in those areas where a competition isn't a good fit. It just means that we're pretty laser focused as a small and agile team on the specific thing that we know we do very well. And so yeah, so some of the characteristics that we are looking for in our competition data sets, and I'm happy to talk one-on-one with anyone who is interested or thinks that they have a good competition idea and a data set, are the size of the data set. And this is kind of a sweet spot sort of situation, a Goldilocks situation, where you're trying to get a data set that's large enough that it has signal, and that it can be predictive of what you're looking to target, as well as not so large, so under terabytes, in
Yeah,
order to make it manageable for people to actually get their teeth into.
run it on the
Um,
laptop. Yeah.
Yep. And then that there is a labeled ground truth is the second thing. So that's the target variable that you're looking to predict. And typically we like to see that there has been a little bit of work on the problem that has been done by that team, so that it kind of does prove that there is some signal in the data set. Those are kind of the core things. Obviously, there are a lot of details that we go into once we know exactly what type of problem it is. Because if something is a natural language processing problem versus a basic tabular problem, we look for different things in the data set.
Makes sense. Thank you.
Mhm.
So I'll move on to Mihali's question. Do you have any discussion group or anything dedicated to data visualization?
Yes. So we have both, excuse me, courses. Or a course about data visualization specifically. We also have uh, a community, I believe, that we just launched talking about data visualization, as well as I would say that if you go onto the data sets part of our platform, the public data sets versus the competitions, the data sets portion tends to be filled with a lot of visualization notebooks versus modeling notebooks.
Mhm.
And that's usually because of the nature of those data sets. When we aren't putting it, when we're not framing the data set around a specific problem that you're trying to predict, you'll see fewer algorithms and you'll see more exploratory data analyses. I mean, even if you actually go, so that 2020 data science and machine learning survey that I mentioned, we actually every year we create it as a data set too. And so people go in and they have access to the same data we do, and we put out our executive report that shows all of the trends that we've seen, but then people do even more amazing things with that data set. We also have something we call meta Kaggle, which is basically a data set of activity on Kaggle, that obviously that we're allowed to publicly release, but then people can kind of like do data analyses and visualizations on Kaggle data, data about Kaggle.
We've
Just
done some work on that, by the way.
yeah. Oh, cool.
Yes, on
Yes.
that data sets. Yes.
Oh, nice. Yeah, yeah. So there's a lot in there, especially in the data sets part, I think, where you're going to see a lot of EDA and visualization work.
Thank you. Thank you for that. Gianfranco is saying, thank you for your presentation, Julia. A tricky question for you, perhaps. Do
Yeah.
you see the risk of a commodization?
Yeah.
Commodity, yes. So do you see the risk of data science talent becoming a commodity as the volume, the number of users on Kaggle grows, the number of competitions grows, and then the prices go perhaps lower per individual competition? And in other words, Gianfranco says, is Kaggle the mechanical Turk of data science? Smiley face.
Yeah, we have been compared to Mechanical Turk or Top Coder. I do think that there are some components of those platforms that Kaggle mirrors, in the sense that, you know, we are seen as crowdsourcers, in the sense that we have a crowd, and they're being sourced for their talent towards a problem. I don't. I guess I maybe don't have quite as cynical a view of things, in that I think that data science is a field that is continuing to grow in interest and also in technique and methods. And so it's no longer just, you know, simple just random forest and decision trees. You have so many different branches of how you can approach problems, that a lot of it is about, and the way we, I'm probably like a broken record at this point, but that we kind of center Kaggle around is really learning all of those techniques that might be applicable to what you're trying to do. And so in that way, I see Kaggle more as a place for people to pick up the things that they don't have, or to share the things that they want to gain, or that they want to share with others that they have gained already. And I don't think necessarily that it's like, you know, a marketplace for people just to get dirt cheap models. And part of that is also the curation of the type of work that we do behind the scenes, just to ensure that the way people are approaching, the way that customers are looking at this, is also that, you know, that this is not, you know, a readily available model that you plug into production, but it's the way that a way that you can kind of learn more about the problem that you're trying to have solved, through the collective mind share of the community.
Thank you for that. Let me see. There was something else from Alexandros is saying, hello and thank you for your presentation. One main criticism about Kaggle is the fact that the datasets are provided clean, which is far away from real life data science projects. Could you comment on that decision and why you decided to focus on the analysis part rather than doing challenges that also include these thankless tasks of curating the data and pre-processing that takes quite a bit of time?
Yeah. So a couple things on that. First is that the measurement of how clean a data set is a little bit difficult thing to tackle, in terms of the way in which we think about competitions on Kaggle. And as you've observed, the cleaned data sets approach is intentional, in that we want people to be able to jump right into creating and modeling on that data, then rather than spending, you know, half their time just cleaning the data set. And so the idea is that we are specializing kind of around this area of modeling and algorithm production, rather than the other bookend pieces. So we are de-emphasizing the cleaning part of it. as well as the latter part, which is the actual productionization of the or deployment of the model, right? And so we believe that by focusing, we can kind of really hone in on an area where we've been quite successful, and also really kind of center around an area where people can learn quite a bit around kind of the nuts and bolts of machine learning. And so those core elements of data science modeling are kind of where we have focused our energy on. And that's just, really based on our approach.
Yeah.
Yeah.
I think it's also what you were saying earlier around competitions, and what drives people to improve themselves is the fact that there is that benchmark that they can measure themselves against, and so on and so forth. So if
Mhm.
lots of them need to spend lots of time in cleaning the data, they might give up before they get to that initial leaderboard entry, which will sort of drive them to continue. A final question from me.
Yeah.
So the you mentioned that you want to have competitions from all sorts of areas, and certainly the list of clients is really impressive. So do you use any heuristics or algorithms to know in advance how successful a competition is going to
Mm.
be?
We don't formalize the heuristics, but we do have, just based on experience, kind of a knack for knowing which ones are going to be more widely attended than others.
Mhm.
So a couple of those characteristics are, one is the data type. We always see that tabular data types are more popular. It's because obviously you could approach the problem in so many different ways. Even if you are, work in only Excel, you could potentially still compete in a Kaggle competition that has tabular data, all the
Mhm.
way to people who are trying to do more advanced techniques.
Mhm.
So the data type. Second is the size of the data. So I mentioned that sweet spot. Usually if a data set goes above, I'd say maybe, let's say 100 to 200 gigabytes in data size, and obviously there are other components to data size than that, like how many files there are or what the data type is. We will see participation drop off at that point as well. People, especially working in cloud-based environments, might not have the access, the compute resources to be able to work with or model on a data set so large. The other piece we see is around the sort of topic often. So sometimes we'll see excitement around certain topics. This is the more unpredictable part, I think, of Kaggle is we could put out some, I think one time we put out something that had to do with something deeply scientific, and it was very popular, and it was something that we wouldn't have expected to be so popular, but people really, no matter whether they were actually physicists or not, were actually interested in it just because it was they could kind of take the subject matter expertise out of it and just look at it for the data that they had in front of them.
Mhm.
And so that's another aspect. The other I would say is there is an aspect of the prize money that factors into it. Our minimum prize pool that we ask of our hosts for featured competitions, these are commercial hosts, is $25,000. That minimum lowers a little bit for research organizations who may not have the funding to support that. Um, and uh, and then our prize pools have gone up to, I believe, $1.5 million. There is kind of a point where I guess you kind of reduce your return on the investment in terms of, I think if you get above like $500,000, then you're pretty much getting the same sort of population of participation. Um, but yeah, so money does factor into it. Mostly it's just that as long as you avoid the too low
Yeah.
target, then you're still kind of seeing similar. And we also try to curate that a little bit. So if we know that it's a difficult problem and it's a commercial organization, then or even like, for example, financial services problem, then we try to make sure that they understand that the perception is that you should be able to be putting up more money than a research organization, for example. So
yeah.
so those are a couple factors.
Cool. I'm gonna, if you're okay with that, I'm gonna ask a final question. We just came in, and then we're gonna wrap this up.
Sure.
I'm sure there's much more we can talk about. Juan is saying, very interesting presentation. Taking into account that people aren't always data scientists, how would you advise building an internal or an enterprise data community that also is perhaps accessible to business users rather than data scientists?
Yeah, that's a really good question. I think that it obviously helps to be able to have a way that people can collectively centralize their sharings. I imagine that in a office or business setting, especially now, people are not always co-located, and that people who are interested in data and working with data could be located in any real any department or area of an organization. And so finding a way to really kind of like centralize that community so that people can share what they're working on or get insights from others. I'm privileged to work at a tech company. So Kaggle is owned by Google, who does this quite well. But it's largely centered around the fact that like we are a culture at Google um, of tech innovation and data innovation, and so everyone, even from whatever sector of Google, is really centered around innovating around data and technology. And so it's also, I think, partially a culture aspect when you're trying to build a community within an organization that might not be accustomed to having data-centered thought. And so,
So,
hope that helps.
culture is absolutely important. All right. Thank you so much, Julia, for your presentation, for the discussions. Thank you, everyone, for the questions. And just to say that we have a final webinar coming up between now and the holidays. So in 2 weeks, we're going to be welcoming Mathilde Huang, who's in charge of open data at ETA Lab, which is the French Prime Minister Task Force for Data Policy. So she's going to tell us about what they have done recently in the Open Government Data Portal in France. Thanks again for joining. Thank you, Julia. Bye-bye. Have a nice evening, everyone in Europe, and a great day, Julia.